Unit 2, Section 3.2 Worked Examples. Construct a truth table for the following statement. In the homework, sometimes in my math lab, they only have you put in certain columns in the truth table. Some students are able to visualize and fill out those columns without creating the entire truth table, but I would suggest that you build the entire truth table. I think it makes it much easier to work the problem. So I've gone ahead and created the truth table, and we've got two simple statements, so there's 4 cases here. And I've broken down the compound statement that we want to evaluate into columns that correspond to either simple statements or decisions that have to be made. And you see my truth table here. And I've labeled the columns where you start. So if you notice, the first column has negation P, and I've taken the truth values for P, and I've negated those and put them in the column. And then the second column are the Q truth values. And then third column, we're going to make a decision with a connector of and. And remember, that is only going to be, that's a conjunction, is only going to be true when both simple statements are true. And I only see that in the third case. So I'm going to go ahead and put in a true there. And the other 3 cases are false. And then the final column in the truth table is a negation of that column that we just made a decision of. So if I move over here, I'm going to have a true, and a true, and a false, and a true. And this, so in the table above, you're going to be putting in this column. This will be column 3 in your full truth table, and this would be column 4 in the table that I did below. Now let's do one with 3 simple statements, which means there are 8 cases. And again, they're only asking you this time to put in the final column, and I think that's quite difficult without building the entire truth table. So I went ahead and I set up the truth table down, the whole truth table here with the 8 cases. And again, I've labeled the columns. First, I brought the p-values over in column 1, and then the negation of Q into column 2, and the connector there is an and. And again, that's going to be true when both simple statements are true. And I notice the only time that happens is in the third and the fourth case. And I like to go ahead and put those in as true, and then fill in all the others as falses. Okay, now we're not finished yet. We still have another column to go. And so I'm going to go over here, and I've pulled over in column 4 the negation of the R's. And now I'm going to cross out the columns that I'm done with so it's less confusing to me. And I'm now comparing 3 with 4. Let me erase that for a second so that's not confusing. Let me go back here for a minute. I'm going to use red. I'm comparing column 3 with column 4, and the connective again is an and. And so what am I looking for? I've got to have 2 true statements in order to have a true compound statement, and I only see that in the 4th case, and everything else is false. So I can go ahead and put my falses in, and I apologize for my pen. It's not cooperating as much as I like it to. There we go. So the only time that this was true is here in the 4th case. And this again, this would be column 5 that would be entered into the My Math Lab homework problem. All right, on this problem here, the first thing they want you to do in the little truth table they've entered there, and this one's a pretty simple one, and you may be able to do this without creating the whole truth table, but you've got to go ahead and write this compound statement symbolically. It is false that the rice has been cooked and the wine has been chilled. It is false that becomes negation. The rice has been cooked, P, and the wine is chilled. And that's the first thing you're going to do, and that's a drop down actually in the truth table in the homework problem. And I've gone ahead and I've created the whole truth table here, same way I did before. And again, this is a pretty simple truth table. The conjunction, the only time it's true is when both simple statements are true, which is the first case. And then you're going to negate those, so you're going to get a false, true, true, true. And again, this is the column right here, column number 4 from my full truth table that's going to go into the homework problem. The next type of problem you're going to see, they're going to give you a compound statement, and they're going to give you the truth values. They're going to give you basically 2 cases from a truth table and ask you to find the final truth value of the compound statement given the truth values for the simple statements. So the first example, here's the compound statement. I've put it down for A and B. And first they told me P is true, so I'm going to go ahead and write the truth value below. So not P is going to be false. And Q is true, so not Q is going to be false. And R is true, so not R is going to be false. And again, Q is true. So if I look on the left side, I've got a false. My connective is an and I've got a true here, but the compound statement is going to be false because the connective is and we have to have two true statements. In the second example, P is true, so this is going to become false. Q is false, so not Q is going to become true. And R is false, so not R is true. And Q was false. And on the left side, I've got a false. And on the right side, I've got a true. So again, the second set of conditions also gives me a false compound statement. And the last kind of an example is what we call an application. So they're going to give you a graph or a table, and they're going to give you a compound statement, and they're going to step you through. It says 4% of Americans get 4 or fewer hours of sleep each night, or 32% get 8 or more hours of sleep each night, comma, so you know you've got parentheses, and 30% get 6 or more hours of sleep each night. And we're going to do each simple statement first. So the first simple statement, 4% of Americans get 4 hours of sleep, 4 or less hours of sleep each night. And if you look at the table there, that actually is true. And the second simple statement is 32% get 8 or more hours of sleep. That's also true. The third simple statement, 30% get 6 or more, and that's false. 6 or more would be, oh my goodness, a lot more than that. So now let's drop the truth values down here. So we've got 4%. This part was true. Or this was true. And a false. And so therefore this is going to be true and false, which makes the compound statement false.